This video is on the inverse tangent function. So if you are not in class for the inverse sine and inverse cosine function, please go back and watch that previous video or else you will be confused. For your note packet, this video is going to cover pages 3 and pages 4. So just like the inverse sine or the arc sine was defined by the angle whose sine is equal to x, the inverse tangent function is defined as the angle whose tangent is that x value. So to get a better understanding of why we're choosing to define by restricting the domain to negative pi over 2 to pi over 2, looking at this graph of our tangent of x, we can see it does not pass the horizontal line test, so its inverse is not a function. However, if we decide to restrict the domain from this asymptote here at negative pi over 2 to this asymptote here at pi over 2, then it will pass the horizontal line test, meaning its inverse is a function. So the inverse tangent function is defined from negative pi over 2 to pi over 2. Just like inverse sine and inverse cosine, there are two different notations for inverse tangent. We can say it is finding the arctan of that value, or again, that tan to the negative first, but we call that inverse tangent of x. Whenever I have an inverse tangent function problem, I tend to draw this little semicircle that you see down at the bottom. It's very similar to our arc sine or our inverse sine one, or rather it's identical because just like inverse sine, inverse tangent is defined from negative pi over 2 to pi over 2. So make sure that you're changing these values that are in quadrant 4 of your unit circle to negative pi over 6, negative pi over 4, and negative pi over 3. To look at what the graph of our inverse tangent function looks like, I'm going to be looking at these 5 main points here. So we're going to look at negative pi over 2 and pi over 2. We're looking at pi over 4 and negative pi over 4, and then at 0. So remember, when you are calculating tangent, it is always going to be y divided by x. So we'll go to pi over 2 here. That has the point 0, 1. So when we do 1 divided by 0, that gives us undefined. However, for our angle measure of 0 all the way over here, that gives us the coordinates 1, 0. So 0 divided by 1 is 0. For our pi over 4s, those are our values of root 2 over 2 and root 2 over 2. So when you do the y divided by x, root 2 over 2, divided by root 2 over 2, you get just 1 or negative 1, depending on what quadrant you're in. You can see here's our graph of the inverse tangent of x. So you can see the domain here is going to be all real numbers. So we can take the inverse tan of any value. So unlike inverse sine and inverse cosine, where we can only take the inverse sine or inverse cosine from numbers between negative 1 and 1, we can take the inverse tangent of any number. And we're restricted here for a range of negative pi over 2 to pi over 2. It is important to still familiarize yourself with how to calculate the tangent of pi over 3 and pi over 6. So again, as I said, tangent is sine over cosine. So just as a reminder for pi over 3, those give you the coordinates of 1/2 root 3 over 2. So when you're calculating your tangent, you are doing root 3 over 2 divided by 1/2. Remember, when you are dividing fractions, you multiply by the reciprocal, and then our 2's cancel, so we are left with just root 3. So therefore, the tangent of pi over 3 is root 3, and then the tangent of pi over 6 using a similar math is going to be root 3 over 3. Just as a reminder, I'm not going to assess you on graphing these inverse functions. So if you take a look at the bottom of your page, those last 3 graphs, you can copy them down from the notes that I provided on Finalsite. However, that's just a refresher. I will not test you on the graphs of those. So just as a summary of our inverse functions, so it's important to note that the values of your inverse trig functions are always in radians. So for our inverse sine function, we can only take the inverse sine or the inverse cosine of negative 1 to 1, where we can take the inverse tangent or the arctangent for all real numbers. However, our range is different. So for arc sine is defined from negative pi over 2 to pi over 2, so I tend to make that semicircle involving quadrants 1 and 4. Inverse cosine is defined from 0 to pi, so I tend to make my semicircle going in from quadrants 1 to 2. And then inverse tangent is defined in the same values where inverse sine is defined. I'm not going to be picky with your brackets or parentheses. Just know that there's a parentheses for inverse tangent because we had those asymptotes. Again, you can skip this section, so we'll turn to the back page of your notes. Now we're going to find the exact values of some extra problems involving inverse cosine and inverse tangent. So again, when you're finding the arc cosine, that's the same thing as finding the inverse cosine. What you're finding what angle measures have a cosine of this value, √2/2. So remember, inverse cosine is defined from 0 to pi. I just labeled pi over 2 to give you an idea of what that semicircle looks like. So remember, cosine is the x value for numbers on our unit circle. So we're looking in those two quadrants, what angle measures have an x value of √2/2. That's going to happen over there at the right at pi over 4. So pi over 4 is the arc cosine of √2/2. Similarly, the arc cosine of -1, what angle measure has an x value of -1? That's happening over here at pi, and therefore our angle measure is pi. You should try the third one on your own by pausing this video, and then I will go over it after you unpause it. You tried the inverse cosine of -1/2, and you were able to see that that answer was 2 pi over 3. Now for the arc tangent, so remember, tangent is defined as doing sine divided by cosine. So on our unit circle, that's y divided by x. So we're finding that when we divide our y divided by x, when that is equal to 0. In order to divide two numbers to equal 0, our numerator must equal 0. So we're looking to see when y is equal to 0. And again, arctan is defined from -pi over 2 to pi over 2. So in these two quadrants, when do we have a y value equal to 0? That's going to happen right over to the right there at 0. So that answer is 0. Again, pause this video, try to answers number 5 and 6 on your own, and then you can start the video up again to make sure that you got it correct. Your answer to number 5 is -pi over 4, and your answer to number 6 is pi over 6. So here's the reason why. In order to divide two numbers to equal -1, both the top and the bottom number must be the same number except one is positive and one is negative. So that's going to happen at our √2/2 and -√2/2. So again, we want to be in either quadrants 1 or 4. Now remember, do not refer to this as 7 pi over 4. We need to refer to that angle as -pi over 4. Do not get tricked by that. For number 6, the inverse tangent of √3/3, this might involve some guess and check. You know that this is either going to be your pi over 6, which is √3/2 1/2, or your pi over 3, which is 1/2 √3/2, because we have that √3 in there. Since in the previous slide, I already calculated the tangent of pi over 3, I'm going to show you what it would be if it was pi over 6. So again, we try out √3/2 1/2. So we're doing this y value divided by the x value. Remember to flip the second fraction. You multiply straight across, our 2's cancel, and then we're left with 1 over √3, which rationalizes to √3/3, and that was the number we were looking for, so the inverse tangent is pi over 6. I will be posting a Go formative online that will test your knowledge on inverse sine, inverse cosine, and inverse tangent functions. I will provide a grade for those who complete it as well. It is great practice because these will show up on your test when you return. Another way you can evaluate these is with a calculator. So if you're checking your work with a calculator, always make sure it's in radian mode. So if we want to find the arctan of -8.45, using your calculator, again, make sure you're in radian mode, which I am. There's no arctan button, but it's the inverse tan button, which we did introduce in a previous section. So I want to hit second tangent and then type in my value of -8.45. And we can see we get -1.453. So number 1 is -1.453. Number 2, we want to find the inverse sine of 0.2447. So again, we have inverse sine, and we get a value of 0.2472. Just make sure you round correctly. It doesn't say exactly how many to round to. And now look at number 3. We have the arc cosine of 2. Again, that's the same thing as inverse cosine. So we're going to find the inverse cosine of 2. But lo and behold, we get a domain error. And again, that's because our inverse cosine and our inverse sine functions are only defined from -1 to 1. There is no value on our unit circle that has a cosine of 2. So you can say that there's no solution, or you can say that none exist. Either one of those would work. So again, now take the time, make sure you copy down your notes, and then go ahead and answer those questions on Go Formative.